Without using 10, show and prove that any whole number n, any non-zero number y, that y to the negative 1 to the n power can be shown to equal y to the negative n power. In order to not use 10, we need to know what 10 is. So if you look down here, it's saying you can't use the rule that says if you have the same base multiplied together, you can add the exponents. So for these, we can't use that rule. But I think it might be wise to try and avoid 11 as well. 11 says that if you have a power to a power, you multiply them. In my opinion, I think it's going to be best to try and use 9, where you have a negative exponent, and when you move it to the bottom, it becomes a positive. So here I have y to the negative 1 to the n power. If I change y from the negative 1 power to a positive 1, it goes in the denominator. Then I have 1 to the n, and I have y of 1 times n power. 1 multiplied out any number of times just gives us 1, and 1 times n is n. Now I can work backwards using 9, because I have a positive n here. To put it in the numerator, it has to switch back to being a negative. So it goes back to a negative n, which is what we wanted. Here's what we started with, and here's what we ended with, which are both of the pieces we were trying to show. And you can say this one was from 9, and then this one was from 5, and then this one was also from part 9, switching it back to there. Okay, number 4 says without using 13, we need to show this. So let's look at what 13 says. 13 says we can't use the rule, even though it's true, that when we have them divided, we can subtract the exponents. We're going to try and prove it without using that rule. So instead, we might use part 9 again with that negative exponent moving to the opposite side. So if it's in the numerator, it goes into the denominator. If it's in the denominator, it moves up to the numerator. So here, using that 9 rule, if it's in the numerator, I can move it into the denominator by changing the exponent from a negative to a positive. 2.8 to the 7th. Now, using 6, I can add those exponents together because they have the same base. So I get 1 over 2.8 to the 12th power, because 5 plus 7 is 12. Then going back to 9, since I have a positive in the denominator, I can move it to the numerator as long as I change it from a positive to a negative. Here's what I started with and what I ended with, and how they connect to what the problem is showing.